Hello, I'm Dane, and this is Dane Explains. It's been known for over 100 years now that the closer you get to the speed of light, the more bizarre things get. Time runs more slowly, and the shape of objects distorts. However, I've bumped into a lot of people who either don't care to understand or outright reject the idea because it's hard to wrap their heads around. But there is a simple way of visualizing that makes it easy to understand, without any math. Let me explain. First, let me start off by mentioning that I didn't come up with this way at looking at the universal speed limit known as the speed of light. In fact, I think it might have been Einstein in his special theory of relativity. But I'm sure someone will correct me in the comments if I got that wrong. One of the brilliant things Einstein did was to imagine space in 4 dimensions. 3 dimensions of space and 1 dimension of time. But instead of trying to imagine time as a series of unfolding events, he imagined time as another spatial dimension, like the other 3. But unlike the spatial dimensions, objects can only move in one direction in the time dimension, and that's into the future. Now, it's pretty hard to imagine things in 4 dimensions, so it helps to convert one of the spatial dimensions to the time dimension. And for simplicity, let's also throw out one of the spatial dimensions as well. I'm horrible at 3D animation anyway. Now we have 1 dimension of movement and 1 dimension of time. Also, there's another thing you have to keep in mind, and that's everything always travels at the speed of light. Never faster and never slower. If it's not traveling at the speed of light in the spatial dimension, it's traveling at the speed of light in the time dimension. The idea may seem absurd, but functionally speaking, it's what's going on in reality. I did a video on it, which I'll link in the description if you're interested. There are also many great videos others have done out there, if you're not convinced by that one. Now that everything's set up, imagine 2 spaceships sitting in space side by side. This means that in the time dimension, they're traveling at the speed of light. If one of the spaceships starts to accelerate in space, its overall speed doesn't actually change. Only its angle of movement between space and time does. Just as if you were walking and suddenly changed direction but kept going the same speed. This means the ship starts to slow down in time. If it went very near the speed of light and someone in the stationary ship could see a clock on the moving ship, then it would appear to be going more slowly than their own clock. This effect is called time dilation. You can imagine this like moving a game board piece, where the moving ship has fewer steps in time because some of the steps were taken in space instead. Another effect is length contraction, which means things moving very fast also contract in length. So when you start to move in space, the angle of your movement in the space and time dimension changes. At least as far as we can tell, objects have no thickness in their time dimension. So if someone watched a ship speed by near the speed of light, the ship would appear to be squashed in the direction it was moving in, because the angle of the ship is changing in space and time. The faster the ship goes, the thinner it gets, and the slower in time it travels. Keep in mind these are just simplified visual aids to help you imagine what's going on. Things are obviously much more complicated under the hood. Now, there is a big thing I've skipped over, and that is relativity. If you were a person on the moving ship, or let's call it the accelerated ship now, since the real difference was that they were both next to each other and not moving relative to each other. But if you were on the accelerated ship, you'd see all the same exact things happen to everyone on the non-accelerated ship as if it was the ship that was being accelerated, because your perception is relative to your own ship. The person on the ship sees all the same things as the person on the other ship, but to them the non-accelerated ship is the one moving more slowly through time and contracting in length. How could that be? Who's actually moving slower through time and who isn't? To make things in my example easier to understand, I omitted the non-accelerated ship's perspective. However, this was reconciled by Einstein in his general theory of relativity, which he published after his special theory of relativity. But we'll talk about that and the perspective of the accelerated ship in another video. So, subscribe and ding the bell to get notified when I release that one. Thank you for watching. If you like this video and other topics ranging from theology to science, please press the like button. Also, please support me on Patreon to get extra content and special perks. Link in the description. The more people support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.